Stuck on in waiting endless nights to get a call. Hung up on you. I wonder, do you ever think of me too? I'm stuck on
In this video, you will learn to convert the general equation of a circle to standard equation using the completing the square method. Then, to change the standard equation of a circle to general equation by expanding the binomials using the perfect square trinomial formulas. Also, to derive formulas we will use to easily convert the general equation of a circle to its standard equation, and to draw a conclusion about a circle based upon the length of its radius. In addition, the video includes nice to know and or must know to increase your knowledge about the lesson. Let's start this video by a review. We have learned that conic sections were described by the general equation ax squared plus bx plus cy squared plus dx plus ey plus f equals 0. In this lesson, we will convert a circle from this equation to its standard equation denoted by quantity x minus h squared plus quantity y minus k squared equals quantity r squared, where h and k are the coordinates of its center and r is the length of its radius. Also, we will see that it is possible to bring the standard equation back to its original form. So how are we going to convert general equation of a circle to its standard form and vice versa? We will use the completing the square method to convert the general equation of a circle to its standard form. On the other hand, we will use the perfect square trinomial formulas to bring back the standard equation of a circle to its general form. The completing the square method is used in this lesson as a technique to express the left side of the general equation of a circle into two perfect square trinomials. Doing such will enable us to convert such equation to its standard form. While the perfect square trinomial formulas in this lesson are used to expand the two binomials in the left side of the standard equation of a circle. Expanding these binomials allow us to bring back such equation to its original form. Is it possible to right away know whether a quadratic polynomial of the form ax squared plus bx plus c equals 0 is a perfect square trinomial? The answer is yes. To do that, we can use the formula b squared equals 4ac. Assuming that the quadratic polynomial is arranged according to its degree, the value of b in the formula is its second term, while a and c are the first and the last term respectively. Here are some examples of how to know if a quadratic polynomial is a perfect square trinomial. These are also used in our examples later on. I know that you are now excited to compute, but first, please tell me one benefit of converting the general equation of a circle to its standard form that you now reckoned. Touché! Among others, it is more convenient if a circle is in its standard form because we will easily identify its center and the length of its radius if we are asked to graph it. Very clever, huh? Now, let's solve. Let's say we were asked to change the general equation of a circle x squared plus y squared plus 10x minus 14y plus 25 equals 0 to its standard form. Then, we also need to identify the coordinates of its center and the length of its radius. You know that I love each of you, so I will make this less stressful. Hence, I devise suggested steps you may choose to follow when converting general form of a circle to its standard form. I said in the start of the video that we will use completing the square method for this. So, step 1 requires us to group the given general equation according to its variables. Then, we will transpose the constant term to the other side of the equation. Aside from transposition, one may also apply in this the subtraction property of equality, or SPE. Therefore, I will have a group for x variables denoted as quantity x squared plus 10x. Then, another group for y variables denoted as quantity y squared minus 14y. In between these two groups is the addition operation, and they are both equal to negative 25. In step 2, we need to make sure that the coefficients of x squared and y squared, or the a and b, are both equal to 1. All good. Their coefficients are both 1. Did you know that this step is essential to follow in our future lessons about ellipse and hyperbola? In step 3, we need to perform completing the square by taking the half of coefficients of x and y, squaring them, and adding them to both sides of our equation. Let's do it first to the coefficient of x. To get the half of it, I will multiply it by 1/2. So, positive 10 multiplied by 1/2 is 5. Squaring 5 will give me 25. We will do the same to the coefficient of y. Negative 14 multiplied by 1/2 is negative 7. Then, negative 7 squared is 49. Just a word of caution. Did you know that some of my previous students confused squared with multiplying the number by 2? So be very careful. Continuing step number 3, I will now add 25 and 49 to both sides of the equation. Before we proceed to the next step, let's simplify first the right side of the equation by adding together negative 25, positive 25, and positive 49. Since negative 25 and positive 25 will give us 0, therefore, the sum is 49. As you can observe, the left side of our equation is adding two perfect square trinomials. We will express these perfect square trinomials into square of binomials in step number 4. To do this, we will get the square roots of x squared, 25, y squared, and 49. The square root of x squared is x. Then, square root of 25 is 5. The square root of y squared is y. and the square root of 49 is 7. Now, the operation between x and 5 and y and 7 are the operations or the signs of the second terms or positive 10x and negative 14y. Therefore, our equation now is quantity x plus 5 squared plus quantity y minus 7 squared equals 49. In step 5, we will just express the equation in the standard form of a circle where its radius in the right side is squared. In here, r squared is 49. To determine the r, we will just get the square root of both sides of the equation. Therefore, square root of r squared is r, while the square root of 49 is positive and negative 7. Now, since radius is a distance, we will just take the positive 7 and plug it in the standard equation of a circle. Therefore, our equation now is quantity x plus 5 squared plus quantity y minus 7 squared equals quantity 7 squared. The last step is to make a conclusion about the circle. Since the radius r is positive, then the circle being described by the given equation exists. Therefore, the standard equation of x squared plus y squared plus 10x minus 14y plus 25 equals 0 is quantity x plus 5 squared plus quantity y minus 7 squared equals quantity 7 squared. The coordinates of its center are negative 5, 7, and the length of its radius is 7 units. I can sense you are puzzled on how we got C with the coordinates of quantity negative 5, 7 as the center of the given circle. I will leave it for you to think about and explore. In example number 2, we will express the general equation of a circle x squared plus y squared plus 12x plus 16y plus 100 equals 0 to its standard form. But wait, did you find the previous example tedious and complicated? I can feel that you want less complicated and less tedious way of converting the general equation of a circle to its standard form. Hence, let's use the short method. Word of caution: some of you will be perplexed in the next part of the video because we will derive formulas we will use to make converting the general form of a circle to its standard form less intricating for you. Please focus and bear with me as I reveal the beauty of mathematics in the next frames. To derive the formulas, we will also follow the suggested steps in the first example. I will group the equation according to its variables, and the constant term will be moved to the right side of the equation. Therefore, I will have quantity x squared plus dx as the first group, plus quantity y squared plus ey as the second group. Then, equals to negative f. In step number 2, I will need to ensure that a and b, the coefficients of x squared and y squared, are both 1. All good. Now, I will perform the completing the square following the same steps. I will take the half of positive d by multiplying it by 1/2. Now, if I square d over 2, it will give me d squared over 4. I will do the same to the coefficient of y. Multiplying positive e by 1/2, I will have e over 2. Then, squaring quantity e over 2 will give me e squared over 4. Now, I will add d squared over 4 to both sides of the equation. This procedure is the same to e squared over 4. Now, I have quantity x squared plus dx plus d squared over 4 plus quantity y squared plus ey plus e squared over 4 equals negative f plus d squared over 4 plus e squared over 4. In step number 4, I will express the two perfect square trinomials to square up binomials. To do this, I will get the square root of x squared, d squared over 4, y squared, and e squared over 4. To get their square root, we will apply the law of fractional exponent that states that the nth root of quantity x raised to m can also be written as quantity x raised to m over n, where x is the base, n is the root index, and m is the power. To illustrate this, I will use the square root of x squared as an example. In here, the base x squared, the root index 2, and the power 1 are substituted to the formula. This will give me quantity x squared raised to 1/2. I know that when I raise x squared to 1/2, it will give me x raised to 2 over 2. Then, 2 divided by 2 will give me 1. Therefore, x raised to 1 can be simply written as x. Now, I will plug it in the first square of binomial. Following the same procedures, I should get d over 2 for square root of d squared over 4. Then, y for square root of y squared, and e over 2 for square root of e squared over 4. I know that the operation in the square of binomial depends on the operation between ax squared and bx. Since both dx and ey are positive, the operations between x and d over 2 and y and e over 2 are both addition. In step number 5, as you can see, our equation reflects the standard equation of a circle, where quantity x plus d over 2 squared represents quantity x minus h squared. Then, quantity y plus e over 2 squared represents quantity y minus k squared, while negative f plus d squared over 4 plus e squared over 4 is quantity r squared. I will get the formula for h here by equating x plus d over 2 to 0. Then, moving d over 2 to the other side of the equation will give me negative d over 2. Therefore, the formula to find the coordinate h is negative d over 2. Following the same procedure, we shall have the formula for k by equating y plus e over 2 to 0. Then, by transposition or addition property of equality, I will have negative e over 2 as the formula for k. For the formula for radius, I know that I can also rearrange negative f plus d squared over 4 plus e squared over 4 according to its exponents. Therefore, I will have d squared over 4 plus e squared over 4 minus f. I can further simplify this because I know that their lowest common denominator is 4. Therefore, this will give me d squared plus e squared minus 4f all over 4. Then, to get our formula, we will simply get the square root of both sides of the equation. Hence, the formula for r is square root of d squared plus e squared minus 4f all over 4. You can further simplify this formula by getting the square root of the denominator, which will give you square root of d squared plus e squared minus 4f all over 2. So here are the formulas for h, k, and r, which we will use in the short method of converting general equation of a circle to its standard form. Did you see the beauty of mathematics? Very tedious process, isn't it? Now, let's reap the fruits of our labor. I also devised suggested steps to follow when using the h, k, and r formulas in converting the general form of a circle to its standard form. To use the formulas, we need to identify the numerical values of d, e, and f. Following step 1, I will have d equals 12, e equals 16, and f equals 100. In step 2, we will now solve for the numerical values of h, k, and r using these formulas. Let's start with h. The formula requires me to plug in the numerical value of d to get the h value. Hence, I will have h equals negative 12 over 2. Therefore, h is negative 6. To compute for the k value, I will plug in 16, the numerical value of e, to the formula. It will give me k equals negative 16 over 2. Then, k equals negative 8. Now, we will solve for the radius by substituting 12, 16, and 100 to the formula square root of d squared plus e squared minus 4f all over 4. the equation will become r equals square root of quantity 12 squared plus quantity 16 squared minus 4 multiplied by 100 all over 4. Simplifying this will give us r equals square root of 144 plus 256 minus 400 all over 4. Adding 144 and 256 will give us 400. Then 400 minus 400 will give us 0. Now 0 divided by 4 is 0. Therefore, square root of 0 is 0. All we need to do in step number 3 is to plug in the numerical values of h, k, and r to the given standard equation of a circle denoted by quantity x minus h squared plus quantity y minus k squared equals quantity r squared. After substituting -6, -8, and 0 to the standard equation, we will simplify it. The first square of binomial will become quantity x plus 6 squared plus the second square of binomial becomes quantity y plus 8 squared. Then equals to quantity 0 squared. In the last step, we will make a conclusion about the circle. Did you wonder something about the right side of our equation? Please have a look. What will happen if the length of the radius of a circle is 0? Did you know that when r squared is 0, then the circle being described by the given equation will degenerate to a point? I hope you still remember our lesson about degenerated conic sections. This one is its example. Let's have another example. Suppose we were asked to convert the general equation of a circle x squared plus y squared minus 6x minus 8y plus 36 equals 0. So that we can familiarize ourselves with the long method, we will use it again in this example. I will group the general equation according to its variables, and the constant term will be transposed to other side so that we can perform the completing the square later on. Now, we are sure that the coefficients of x squared and y squared are both 1. Let us now perform the completing the square. Let's start first with the coefficient of x. Multiplying -6 by 1/2 will give us -3. And squaring -3 will give us 9. Now, taking the half of the coefficient of y, which is -8, will give us -4. Then, squaring -4 will give us 16. I will now add 9 to both sides of the equation. Also, 16 to both sides too. Afterwards, we will simplify the right side of the equation by combining -36, +9, and positive 16. It will give us negative 11 as sum. In step 4, we will change the two perfect square trinomials to square of binomials. To do this, we need to get the square root of x squared, 9, y squared, and 16, which are x, 3, y, and 4 respectively. We are sure that the operation between x and 3 and y and 4 in our two square of binomials are both subtraction because 6x and 8y are both negative. Oops! Did you also see what I saw? Legend! The length of the radius of the circle is negative. What does it tell us about our circle? Touché! If r squared is negative, then the circle being described by the given equation does not exist. Our conclusion? This implies that there is no point in the plane that satisfies the equation x squared plus y squared minus 6x minus 8y plus 36 equals 0. Therefore, the circle does not exist. Now, let's learn how to bring back the standard equation of a circle to its general form. To do this, we will use the formulas for expanding the square of a binomial. In addition, I also came up with suggested steps you may wish to follow if this task is something new to you. In step 1, we will expand quantity x plus 5 squared and quantity y minus 7 squared into perfect square trinomials. To do this, we will use the perfect square trinomial formulas. The formula says that if the square of a binomial is of the form quantity a plus b squared, then it can be expanded using the formula a squared plus 2ab plus b squared, where a is the value of the first term of the square of binomial, while b is its second term. We will use this formula to expand the quantity x plus 5 squared because such is of the form quantity a plus b squared. Here, our a is x and our b is 5. Substituting these to the formula, we will have this. Then, by simplification, this will give us x squared plus 10x plus 25. Since the quantity y minus 7 squared is not of the form quantity a plus b squared, it is of the form quantity a minus b squared, we will use the other perfect square trinomial formula, which is a squared minus 2ab plus b squared. Here, the value of a is y and b is 7. We will substitute these values to the formula. This will in turn give us y squared minus 14y plus 49. As you can see, we already expanded the two square of binomials. The step 2 simply requires us to simplify the radius in the right side of the equation. Therefore, quantity 7 squared shall give us 49. In step number 3, we will combine like terms. Since the only like terms are our constant terms, I will move 49 to the left side. Then, I will combine it with positive 25 and positive 49. Therefore, its combination should give us 25. Therefore, the general equation of quantity x plus 5 squared plus quantity y minus 7 squared equals quantity 7 squared is x squared plus y squared plus 10x minus 14y plus 25 equals 0. To sum it up, here are the nice to know and also must know we have learned from this video about a circle. Conclusion number 1. If the radius of a circle is positive, then the circle exists. Conclusion number 2. If the radius of a circle is 0, then the circle degenerates to a point. Conclusion number 3. If the radius of a circle is negative, then the circle does not exist. Did you find this video helpful? For more Siknayan, please like and share this video and subscribe to my channel by clicking the subscribe button below and activating the notification bell. I expect to see you all again soon in Siknayan. Problema sa Siknayan, isik mo na yan kay Migo Mendoza.